and also the remaining quizzes. So, so this quiz 8, which I'm currently marking, is the last one before the Easter break, and then you have quiz 9 and quiz 10, which will be after the Easter break, right? Okay, so when you return after Easter break, you can start working on quiz 9 and 10. And this week, we have no tutorials this week, so we only have this lecture today from 9 to 10 today, and also a lecture on Thursday from 11 to noon. So we just have the 2 lectures, and I'm recording the 2 lectures right now, so you can view them later on if you want to see them again, or if your friends haven't been able to come to the lectures today, then you can ask them to. Look at the the videos and so on. Okay. Do you guys have any questions? I mean, hello guys, are you okay? So this week what I'm gonna do is I'm gonna do more examples on the stuff I covered last week, which is on confidence intervals, you may recall. So let me do, like I think I did. You should look at what the stuff I did last week. You should look at the stuff I did last week. I did, I think, about 3 examples on confidence intervals, if I remember correctly. So let me try to do maybe a couple of more examples today. Are you guys okay? All right. So if you have any questions during my lecture, or you can use your mic, or if you don't want to use your mic, you can use, there is a chat room, a Zoom group chat room. So if you have any questions, you can type your question on the chat room, and I'll be happy to answer. Okay, guys. Okay. So let me start with some examples today. So, all right. Okay, this is where I need to share the screen. So share. Where's my Microsoft? Oh, can't see it. Just a minute. Sorry, guys. Here we go. Oh man, where is it? I can't see it still. I can't see what it is. Oh, here we go. Okay. Hopefully you can see me now. Well, maybe my camera is not all the time on my face, but okay. So the stuff that we did last week was on confidence intervals. Okay. So I think I did. Maybe one of you could remind me. I did 3 examples. So I'm going to do a few more examples today. So let's start with example number 4. Example 4. All these examples are on confidence intervals. Suppose you have a data x. X is just a one single data point from exponential distribution with parameter a. And the question is to find times confidence interval for a. Now, how would you do this, guys? I mean,
He's only here for an hour. Sit down, you sit down.
are you guys okay? Okay, you have a single data point from an exponential distribution with parameter a, and we want to.
Why not?
You've just had loads of protein in the eggs and the beans.
It's hardly any of the beans. How many people we got in there?
Quite a few.
Now, what I'm drawing here, guys, is the PDF of an exponential distribution with parameter a. Okay, and this is the x-axis, and this is the y-axis. The y-axis is the PDF. Okay. Now, what I'm trying to find is I'm trying to find 2 points on the x-axis. So suppose this point here and this point here, so that the area between them these 2 points is equal to is equal to 1 minus alpha. Okay. You see, this is the idea. You see, I think I talked about this last week. I don't know whether you guys remember. To find a confidence interval, you need to start with. I mean, it's always a good idea. Sometimes it's a good idea to draw a picture and find 2 points so that the area between them is 1 minus alpha. So you could take the area on the 2 sides, like this side here. You could take this area to be alpha by 2, and you could take this area here to be alpha by 2. So the total area is 1, as it should be. Okay. Okay. Now the question is to determine the 2 points. In other words, determine this point here and this point here, so that the area between them is 1 minus alpha. All right. Now the question is how to do that. Okay. Let's see. Okay. Let's start with this point here. Oh man. So let me use some other color. No, I don't want red. Okay. Let me use. Okay. Let me start with this point. All right. To determine that point, you have to say that the Cdf of x at this point, say let's call, okay, whatever it is, must be alpha by 2, right? In other words, that's the area to the left, right? Now, I'm sure you guys know what's the Cdf of exponential distribution is. It's 1 minus. Don't tell me you don't know this. It's this, right? I mean, if you look at the handout I gave you at the first week of classes, maybe you throw it in your bin or something. Just kidding. So you see, this is the Cdf of the exponential equal to this, right? So this implies that 1 minus, so e minus ax is equal to 1 minus alpha by 2. right? So x is equal to what, minus 1 over a times log of 1 minus alpha by 2. So this is the point. So what I have shown you here, guys, is the derivation of the point of this point here, right? Okay, now you can do the same thing for this point over here. I mean this one. So to do that, you need to make the same argument, right? Okay, so to make the argument here, you're gonna say fx, the Cdf of x equal to the area to the left of this point is what? What's the area to the left? Talk to me, guys, please. The area to the left of it is, huh? Are you listening to me, guys, or no? Is 1 minus alpha by 2, right? You follow me, yeah? So this implies that yeah, and this implies that EF minus AX equal to alpha by 2. So this implies that X is equal to minus 1 over A times log of alpha by 2. So let me put this in another box. Okay. So basically, I have shown you that so far that, man, can you see what I'm writing, by the way? Let me know if you don't. I have shown you so far the 2 points. I have determined the 2 points such that the area between them is 1 minus alpha. So let me write down what I've just done so far. So what I have done so far is the following: that the probability that sorry. Okay, the probability that x is the exponential variable lies between these two is equal to 1 minus alpha. Okay, so this implies that, okay, now, I mean, we want the confidence interval for A, not for X, okay? So we need to change this into a statement on A, right? And that's what I'm gonna do now, okay? So to make this into a statement on A, you need to do this. So this becomes, excuse me. This becomes like the following. So this is minus log of 1 minus alpha by 2 divided by x, right? Less than or equal to A, and less than or equal to minus log of alpha by 2 divided by x. Okay, so this is, correct me if I'm wrong, I mean, it's quite possible then. So we have rewritten this the statement as a statement on A, the parameter of interest. So hence, conclusion is the following. Hence, all right. So 100 times 1 minus alpha percent confidence interval for A is the following. Okay. Do you have any questions on this so far before I go to the? So please, I mean, either you can use your mic if you have a microphone, or if you don't have one, you can type on the chat box. There's a chat box for the Zoom, right? So please, if you have any questions, please type. So this is example 4, which I just completed. So any questions, please let me know, guys. Okay. Are you okay? No questions? Did I make a mistake or something? Did I make a mistake? This is I'm talking about the exponential. This is exponential, sir. Maybe you came late, sir, but this I'm talking about the exponential distribution. This is the exponential. Look, this is the beginning of the example. Maybe you missed it out. So I'm assuming X has the exponential distribution with parameter A, and the question was to find the confidence interval for A, and that's what I just did, right? So I hope you follow this. Okay. All right. The next example I'm going to consider is example 5. Example 5. So here you have okay, just a minute, give me a sec. All right, you have two independent random samples. The first one is from a normal distribution with parameter A and 1. So A is the mean and variance is 1. And the second one is from a normal distribution with mean equal to B and variance equal to 1. And okay, so we are assuming the two samples are independent of each other, right? And we want to, the question is to find 100 times 1 minus alpha percent confidence interval for A plus B. Okay, so this is a little bit tricky. I mean, not tricky. I mean, if you know the stuff, is everything is not tricky. So here you need to okay, you need to know the stuff. Okay, because we are dealing with the normal distribution, so you need to use the properties of the normal, right? So the first thing you may remember when I talked about the normal, one of the properties I mentioned is the following: that the sample mean of the x's, right, will have a normal distribution with parameters a and 1 divided by, because the variance is 1, but 1 divided by m, right? And also the sample mean of the y's, which is y, which I denote by y bar, will have this. Okay, you follow me? Okay, so I'm sure you know these guys. Now, so if you sum the two, because these are independent random variables, right, x bar and y bar independent because the two samples are independent. So if you sum the two, you will have a normal variable with parameters a plus b and 1 plus m divided by 1 plus n. Okay, you follow me? All right, now this is why you need to use the standardization. So you should subtract a plus b from it, right? What you have is a normal variable with mean equal to 0 and variance equal to this. Okay. And you should do one more thing. You should do you should divide both sides by the square root of this, right? You will have a standard normal variable. You follow me? Yeah. Yeah. So now I'm sure all of you know how a standard normal density looks like. I mean, assume you, okay, let me draw it. If you haven't, I'm sure you've seen this many times already, not just in my course, but in other courses too, that this is a typical shape of a, PDF of a standard normal variable. Okay. Now, the thing is, as I said before in the previous example, we need to look for 2 points. You need to look for 2 points so that the area between them is 1 minus alpha. Okay, so let's take this point and this point, and I want this area here. Okay, I want this area to be 1 minus alpha. Okay, so that means we can take this area here and this area here to be equal to alpha by 2 and alpha by 2, right? And the question is, what are these 2 points here? Now, I talked about percentiles of the normal a while ago. I think you should know. This guy here is what? Is the percentile of the normal distribution with the area of alpha by 2 to the left. So this is denoted by z or z alpha by 2. And this point here is the percentile of the normal with the area of 1 minus alpha by 2 to the left. So this is denoted by this. Do you follow me? Yeah. So this point is this one, and this point is this one. Okay. So what we are saying is that the probability that x bar plus y bar minus a plus b divided by this guy here is less than or equal to this and less than or equal to this, right? Is 1 minus alpha. Okay, you follow me now? Yeah. Any questions? Just use your mic, okay, or write on the chat room. Okay, now if you rewrite this as a statement on a plus b, I'm sure you know how to do that. So as a statement on a plus b, this will be x bar plus y bar minus z or z1 minus alpha by 2 okay, and then is less than or equal to x bar plus y bar minus z alpha by 2 okay. All right, so I'm just rewriting it as a statement on a plus b, because that's what we want to find. Okay, and in the next step, I'm going to use the property that, so using the property that remember this property, guys. This is because of the symmetry of the standard normal, that these are equal in magnitude, right? So using this property, you can write the above statement as follows. Right. So this is the statement. So we have the answer. So hence the conclusion. So the conclusion is as follows. So hence 100 times 1 minus alpha percent confidence interval for A plus B is as follows. So this is the lower end point, and the upper end point is x bar plus y bar plus z 1 minus alpha by 2 plus 1 plus. Okay. All right, guys. So this is example number 5. Any questions on this, guys? Please let me know. Or you can use your mic, or you can use the chat room, or whatever. Yeah. So please, if you have any questions, please do let me know, guys. So once again, there are no tutorials this week. So it's just this class going on right now, and the class on Thursday from 11 to noon are the 2 classes this week, right? So, are you guys okay? Any questions you have, guys? Hello, guys. Talk to me, guys, please. All right. Okay. The next one. Okay. So that's example 5. The next example I'm going to do is the following. Okay. All right. The next example is the following. So let me put the Zoom back on. Okay. Let me share. So this is next example. Is example 6. One other announcement is on Thursday I will start on a new topic which is called testing of hypothesis. So please do ask all your friends to turn up for the lecture on Thursday from 11 to noon, because I'll be talking about a new topic, the topic on testing hypothesis. Okay. Okay, suppose you have a random variable x that has this as the PDF, and we want to find, the question is to find 100 times 1 minus alpha percent CI for A. Okay, and this is, I mean, this is similar to example 4, which I did this morning. So what you need to do is, first thing you need to do is to draw a graph of the density function, right? So that's what I'm going to do now. So I'm going to draw a picture which I'm sure you know I'm not good at drawing anything, but let me try to draw a picture of, man, it's already very bad. Okay, sorry. Okay, so suppose this is 0, suppose this is your A. So the graph will look something like the following. It will be at 0, it will be 0, and at A it will be 2 divided by A. So it's gonna be like a horizontal. It's gonna be like a horizontal. Okay, let me use a color. So it's gonna be like a horizontal line going up. So because it's linear. So okay. All right. So this is A, and this point here will be 2 divided by A. Okay. Now the question is once again to find the points on the x-axis. So we need to find 2 points on the x-axis, this one and this one, so that the area between them is 1 minus alpha. We want this area here. We want this area to be equal to 1 minus alpha. All right. So that means we can take this area here and this area here to be equal to alpha by 2, and this is also alpha by 2, right? Okay, so the question is to determine determine these 2 points, the point here and the point here, right? Okay, let's start with this one here, the first, the lower one. Okay, so to determine this point, you need to set the Cdf of x. All right, you want the Cdf of x at this point to be alpha by 2. So which implies that now what we are given is the PDF, not the CDF, right? So first of all, you need to determine what the CDF is, right? So I'm sure you guys know how to find the PDF, sorry, the CDF from a PDF. Okay, this is what you get. I'm doing integration, guys. I'm sure all of you know how to do this. So x will be equal to a times the square root of alpha by 2. Do you follow what I've done? Oh, you lost. I'm sure you know. This is not really hard stuff, guys. So what I have done is to determine this point here, the lower end point of the confidence interval. that I'm trying to find. To find that, I need to set okay, guys, so you follow what I've done is to find the low endpoint. So I set the CDF to be alpha by 2 and solve for x. And similarly, to find the upper endpoint, you need to, so where am I? To find the upper endpoint, sorry, I messed up here, sorry. To find the upper endpoint, guys, you need to set the CDF of f of x to be equal to 1 minus alpha by 2, right? Which is once again, if you do the integration once again, this is x squared by a squared equal to 1 minus alpha by 2. So x is equal to a times the square root of 1 minus alpha by 2. Okay, all right. So we determine the two points, the lower point and the upper point. So the area between them is alpha by 2. So in other words, what we have done so far is the following. That is the probability that that the variable x lies between this and this is equal to 1 minus alpha. All right. You follow me, guys, or not? Okay, so now we need to change the statement as a statement on A, right? Because we are looking for a confidence interval for A, right? So as a statement on A, this would be the following. So A in the middle, x divided by the square root of 1 minus alpha by 2. That's the low end point. The upper end point will be x divided by the square root of a by 2. Okay, so hence (100 times 1 minus alpha) confidence interval for A, the parameter A is as follows. Is the low end point is x divided by 1 minus alpha by 2, and the upper end point is x divided by the square root of a by 2. So that concludes example 6. Do you have any questions on this, guys? Please use your mic, or you can use your the chat box. Okay. Please let me. Are you clear with this question, guys? This example. So it's similar to example 4 I did a little bit earlier. Okay. So just to summarize, you draw the picture and of the PDF, and then find the 2 points so that the area between them is 1 minus alpha, and that's what I did in here. And then once you've done that, then you rewrite that as a statement on A, right? Okay. Okay, guys. Any questions? Oh, somebody Skyping me now. Just a minute. Let me. Sorry, guys. Daniel, you okay? Everybody's okay so far? All right. So that's the next thing. All right. So that's example 6. Now the next example I'm going to do, which is all right. Okay. Sorry, guys. This is just all right. Next. So the next thing I'm going to do. Sorry, what am I doing? Okay. The next example I'm going to do is example 7, which will be the last one I will do it today. And also, as I said, on Thursday this week, I will start on a new topic, which will be the final topic for the course, which is called testing of hypothesis. All right. So this is example 7. So example 7. Okay. Suppose suppose you have a random sample from a uniform distribution on the interval b to 1. Find find the confidence interval for B. Right. In this, I mean, this kind of question is not so straightforward. So if I ask you a question like this in the exam, sorry, there will be no exam. Okay, sorry, guys. If I ask you a question like this in the future, I will probably give you a hint, right? So the kind of hint will be like this, right? So I will say, okay, let Z denote the minimum of the data points, and then try to find the CDF of the minimum, and then use that to find the confidence interval for B, right? So the first thing I'm going to do is to find the CDF of Z, right, or Z, whatever you call it. Okay. So this is the probability that. Okay. All right. And because we are dealing with the minimum, I'm going to write this as 1 minus the probability that. Okay. And then I will put in the minimum, which is the probability that the minimum of xi is greater than z. Okay. Now, since if the minimum is greater than z, then each element has to be. So this would be the same as saying that probability x1 greater than z up to xn greater than z. Now, because they are independent of each other, so using independence, right? We can write this as 1 minus the probability that x1 greater than z. Okay. And then using the fact they are independently, identically distributed, using the fact they are identically distributed, you can write this as 1 minus the probability that x is greater than z to the power n. Okay, guys. So this becomes 1 minus the probability that x is less than or equal to z to the power n. Now I'm sure all of you know the Cdf of a uniform V1. If you don't know that, you can look it up in the handout I gave you on the first day of classes. So the Cdf of uniform at z or z is the following. Okay, so this will be 1 minus this is what you get. Okay. All right. So this is the CDF of Z. Now you can also find the PDF here, but I mean it's not necessary to find the PDF. But if you want to draw the graph of it, the graph of the density, and you can still find the PDF. So the PDF of Z, which is the derivative of this, will be okay. All right, so this is the density function. Now, okay, now this is where you, okay, if you really want to draw the graph of the density function. Oh, sorry, back to my drawing skills, which is not awful, not really good at all. So you should draw the graph of, so this is this is your V, and this is your 1, and this is Z or Z, and on the y-axis we are drawing the PDF of Z. Now, so you should draw the picture of this. It will look something like, excuse me for my, sorry. will look something like this, right? I hope you can you read my, it will look something like, the graph would look something like this, right? And once again, you're looking for 2 points on the x-axis, so that the area between them, the area between these 2 points is so this area here. Okay, this area, you want this area to be 1 minus alpha. All right, so you want the area here. You can take this area here and the area here to be alpha by 2 each. So, excuse me. So you want so this area to be alpha by 2, and you want this area to be alpha by 2. Right? So the question is to determine these 2 points, right? So let's start with this point here. All right. So to determine this point, you just set the Cdf of z to be alpha by 2. Right. So now the Cdf we already worked out. So is 1 minus. Can I recall what it is? Sorry, 1. Okay, 1 minus z to the power n equal to alpha by 2. Now, if you solve this, I know I'm running out of time, but let me do this quickly, okay? I hope you don't mind. So if you solve this, guys, you will get the following: 1 minus b, 1 minus alpha by 2 to the power 1 over n. So this is what you will get for the lower endpoint, okay? And for the upper endpoint, which is this guy here, okay? For the upper endpoint, you want to set the Cdf equal to this, all right? Which is the same as saying that 1 minus z divided by 1 minus b to the power n equal to 1 minus alpha by 2. All right. And if you solve this in the same manner, you get z equal to 1 minus alpha by 2 to the power 1 over n. Sorry, what am I doing? To the power 1 over n. So this is what you get, okay, for the second point. All right. So what we have shown so far, thank you for being patient with me. So what we have shown so far is the probability that that the z lies between these 2 guys is equal to 1 minus alpha. All right, now you need to change this statement as a statement on B, right? Which I'm sure all of you know how to do, but so if you do that, let me show that. try to show you. So it will be as a statement on as a statement on B. This is as a statement on 1 minus B. This is what you have. Correct me if I'm correct me if did I? Okay, 1 minus B. This is what you have. Okay, and correct me if I'm wrong. It's quite possible that I might be making some errors, but if I make any errors, please do let me know. And finally, as a statement on B, because we are looking for a confidence interval for B, right? As a statement on B, you will have this as right. This is the statement as a statement on B. All right. So hence the conclusion. So this is the end of the call. So sorry for it. I know I have run out of time, but I apologize for that. So the conclusion is that the 100 times confidence interval for B is the low end point is 1 minus z alpha by 2 to the power minus 1 over n, and the upper end point is 1 minus z 1 minus alpha by 2 to the power minus 1 over n. Okay, where z is equal to the minimum of x1 to xn. Okay. All right, I know this example is a little bit detailed, but I mean a little bit involved. So I hope you followed what I did. Did you guys follow what I did or no? Let me know if you did not. I mean, so here, because the question gave you a hint, so you have to first start by finding the distribution of Z, which is the minimum, right? Oh, where am I? Sorry. All right, so here, that's what I did first, to find the distribution of the min, and then the PDF of the minimum, which I plotted here, is a very clumsy plot. You know, it shows you how bad I am in plotting things. Then from the plot, you can determine the 2 points that make up the area of 1 minus alpha in the middle, right? And once you made up those, okay, once you got the 2 points, then the rest is not difficult at all. Okay, guys, any questions, guys? Please let me know. So let me. Hello, guys. Are you here? All of you. So so I will try. I've got a few more scripts to mark today. Sorry, this morning. I will mark them and I will send you the marks for quiz 8 later today, maybe this afternoon, or maybe later this morning. So on next class is on Thursday, 11 to noon, and I will be talking about testing hypothesis, which is the last topic for this course. And also, any questions you have about anything, like not necessarily related to my course, because I know, as you know, these are very difficult times for a lot of people, not just, I mean, including myself. So any questions you guys have, just Zoom me in 24/7, because this is, I mean, this is not an account I created for just for teaching you guys, but it's an account I created just to, you know, have a good chat with all the students 24/7. So any questions you guys have, you know, just Zoom me 24/7, right? Ask anything you like related to the course or not. Okay, all right. So that's why I keep this Zoom all the time, even at midnight or even at 12, anytime, 24/7. All right, guys. Do you have any questions right now or no? Hello. Are you all okay? So I will I will okay, I will upload the video that I just done to the course website, and then you'll be able to see what I did today. And also, I will see you guys on Thursday. So please ask all your friends to turn up on Thursday, please. I'm not happy with the number of people turning up today. All right, guys, bye. Have a good day today, right? Take care of yourself. Bye. அம்மா இங்க வா. காலம் முழுமே கத்துறீங்க 2 பேரும். நான் படிப்புக்கிறது தெரியாது. இல்ல இல்ல இந்த இதுதான் இந்த இவ்வளவு வந்திருக்கு. கடைசி நேரத்துல அவங்கள அனுப்புவாங்க. அவள என்ன வடிக்கிறாளே இல்லையா? சத்தம் போட சொல்லாத. சில பேர் ஆன்லைன்ல நிக்கிறாங்க இப்ப. I need to do all this. கன பேர் எங்க வெளியால ஓடுவாங்க லண்டன். லைட்ட போட பாருங்க. இதே ஆன்லைன் கீழே போங்க, இங்க வர வேண்டாம். Right. Shh, close the door.